the organizers. And so what we're going to talk about today is Hofmann Engineering and our process for improving field service life of critical components. I'm going to talk a little bit about our business, and I think we're best described as making very large pieces of equipment, like our favorite marketing photo. This is a girth gear for a ball mill. Now, every person involved in the making of that gear, from the design team to the fabricators to the machinists, are sat on the gear. So it's a 13-meter gear. We make very big stuff. Now, it has to last a long time, but also, luckily for us, miners are very good at breaking things. And they always want more tons, more life, cheaper and faster, which gives us really good opportunity. Oops, sorry. The company started 50 years ago by two brothers, John and Eric Sr. 1969 they started the business, just the two of them in in Eric's backyard. And they've grown the business substantially from then. They're very practical people. John still comes around the factory. He's 82. They were both tool makers. I think they worked at John Deere for a while, and then they started the business. Very practical, excellent with their hands. They could run any machine, whether it be a gear cutter, a borer, a lathe, and very good at finding solutions. The other key founder is Leighton White, our technical director, and I know some of you, we've already had conversations, some of you people know him, and he was instrumental in bringing the company forward as well. He studied metallurgy, and he brought a lot of that sort of material science to the business. He installed the heat treat operation that we have. And then this is John's son, Eric. Eric went and studied and became a gear designer, and he brought all that capability to Hofmann. So we have a very large facility in Bassendean. We're your friends in Bassendean. Anyone who operates a mine knows they can call us anytime and someone will pick up the phone. We currently have 7 large factories around the world, 4 in Australia. We've just reopened North America by acquisition, and we've got factories in Chile and Peru. So what we're going to talk about is extending field service life by product improvement. Product improvement is a big part of Hofmann's strategy. We like to make things better. It's what separates us from the competition, and it's what adds benefit to our customers. So we're going to talk about that process, how we go about it, and then we're going to show you 3 case studies. These are very recent. They're ongoing or have happened within the last year or 2. And this is just 3 case studies among many items that we're working on. Hofmann Engineering are into a lot of products. We do HBGRs, gearboxes, crushers, rail, automotive. You can see mobile mining, all the major mobile mining equipment, shovels, drag lines, trucks, excavators. And why we like to be in so many fields is that we learn how people do things, what design codes they use, what innovation they're using. I mean, if the people who study strategy may look at Hofmann's and think we're totally unfocused, it's not the case. If you look at what we do, it's power transmission, it's rotating parts, it's crushing, it's wear applications, right? And what we do well is we learn from all products, all different OEMs, all different designers and engineers, and we can bring that technology that we learn from another product or sector and apply it to a different sector. So what's product improvement to us? This is where you can improve an existing product. What's real important to Hofmann Engineering is that you make a meaningful product in terms of the customer. He has a benefit, a significant benefit, in the shortest period of time. So product improvement to us is significantly increasing those benefits to existing customers and ultimately creating new customers. There are 2 popular ways. If you read about product improvement, there's 2 popular ways of doing it. You can add new features to a product, or you can improve existing features. Adding totally new features is a really good analogy. It's like having your own children. You have to love and support them. You have to take them everywhere. Everyone will tell you they're great, but no one wants to keep them. Hence, these are quite risky. You have to be very confident about going out with new features to a market. It requires extensive marketing and support, and generally education for someone to adopt that. So Hofmann Engineering are definitely in the second area about improving existing features. This is a deliberate change based on what customers tell us. And they can tell us this directly or indirectly. They can come to us and say, we got a problem with this crusher, which is an example that we're going to talk about. Can you help us? They can also tell us indirectly or unspoken. And the things that every product manager in Hofmann's looks out for is these three words. When someone is coming to us and they want a repair, a refurbish or replacement, it means an opportunity to do a product improvement. You've got to really find out why they want to do one of these three things. Now, as I previously mentioned, the great things in our fields, which is pretty much resources, more power, more tons, or longer service life. This really resonates with the users of the equipment that we sell to. The way we go about it, and I think several of you may know Hofmann's, and there's usually ex-Hofmann employees in the room, we would like to call it a process, but we're really not that formal when we do product improvement. What we do is we look at what works in other segments, in other products, and we try to transfer that to the specific need. Once we've done that successfully on one or two products, it's all about driving the adoption. So this is where the marketing, this is where the evidence, the case studies, and all that convincing for customers to try it. So we're going to get into 3 short case studies. And the first one is a really good one. The adoption of this product has been exceptional. We were looking at cone crusher heads from about 2006. They come into our shop for repair. So it's one of those golden words where we see an opportunity. And just in the general arrangement, it's item E. So all of these items in a cone crusher, Hofmann have made an improvement on. But the cone crusher head was a particular challenge. It came into our shop, and pretty much what we always saw was cracks, generally in these locations. Loads of cracks, extensive cracking. The good thing was pretty much the only failure mode we saw. So these things failed by cracking, and generally the operators could see the failures 10 to 24 months into service, which is not a good thing for them. These are some examples of the cracks that we saw. So very long cracks, particularly in the grooves and the relief areas. And of the 15 that we studied before we made our first forged head, this is the kind of repair method that had to take place. So huge excavations of these cracks to totally clear it to the crack edge, and then you would fill up with weld. The materials that were used by the OEM at the time was predominantly, they fell into a class L1B, which is a plain carbon steel. No alloying additions, no particular strength, and certainly with the hardness that we were looking at, there was no heat treatment. So the equipment was failing between 10 and 24 months. And what this means for the mine operators, they have to have a spare. So the examples that we have, we got mine operators, they got 4 of these units, they carry 2 spares and they rotate them. And these things get repaired on 16-week cycles, and they're very, very expensive. So what we did, we got down, or we sat together and we thought about how to improve this product. We've been making forged gearing for decades, for nearly 30 years. It's absolutely day-to-day business for us. The process that we use is pretty much all laid out in the gearing standards. And the techniques on forging is to upset forge an ingot that's made to gearing quality steel. So remember, this is a crusher head. Gearing quality steel is some of the best quality steels used in industrial applications. We knew if we upset forge it and got the right forging ratios from a good steel, and you can see how the head is starting to develop from the forging, we're going to eliminate all the casting defects that have the potential to lead to cracking that we saw on the parts that were coming in. So that's what we did. The results were outstanding. The pictures we showed there is the first head that we forged. You can see the shape developing, and then the finished machine product and the heat-treated state. The first one that we put into service was 2018. it's 30 months and the mine operator won't give it back to us. It's just doing campaign after campaign after campaign. We would actually like to see it. We would like to see all these areas to see if we have eliminated the cracking. He won't give it back to us, which is a good thing, I guess. There are now, the adoption is really good. There's over 20 forged heads in operation around the world. The one with the second most service is 26 months. So we're really starting to develop a good product and good evidence that it's going to outlast the cast variant. The benefits for the customer, now these are the things that you sell, is less rotable spares, less time where that spare is away from the plant where they're exposed to a risk of lost production. We believe that just applying what we know from the gearing standards, right, that's all we've done. We've applied what we've known from the gearing standards. We haven't done extensive research. We know it works in gearings, and we've applied it straight to the crusher head, and it's been a huge success. Okay, the next one, these are our friends up in the Pilbara. They brought us a manifold for a diaphragm pump. The problems they were having is that it was failing by internal wear after 18 months of use in service. And they wanted 5 years. They wanted to get this up to 5 years campaign time. Look at the duties. Anyone from the field will know that's nothing special. It's nothing special, those kind of duties. But 18-month service is obviously a big problem for them. We also knew that when we analyzed this, the steels and materials they've used to construct it are pretty average. We're talking about cast T-sections and Schedule 60 pipe. Carbon steel, the internal hardness on an Equitit, and I know there's a whole argument about Equitit, but it was soft, 150 Brunel. This, in a slurry application in iron ore, is not going to last very long. One of the engineering challenges that we have is to replicate the piping pressure code that it needs to be designed to. So what Warren and I have been doing for a long time is selling white iron cast valves to Alcoa. Thousands of them for decades. So we thought, well, what if we tried to, what if we tried to apply this idea of having white iron cast liners inside the manifold? We were pretty confident that would work. White iron, as some of you may know, is absolutely fantastic for abrasion and slurry. High chrome, unheat treated, is about 47 Rockwell. That's easy to make. You can cast it and you can put it in application, and you rely on just the carbides to do the wear work. The matrix will wash out, but it's fairly good. To make something special, you need to heat treat it up to above 600 Brunel. Now that's the hard bit with white iron. There's very few companies that can cast it and heat treat it without cracking. But luckily our supplier has been doing this, as I said, for decades. And what we needed to do was just decide on the shape and the configuration of the white iron inserts inside the manifold. White iron is great. You can determine the carbon volume percent either by calculation or image analysis. Point being, we want as much carbide in that matrix as possible, heat treated to a monazite structure to get the best wear resistance for the slurry application. This is just an excerpt from one paper that I found, and it shows the relative wear in slurry pot tests, mild steel versus a hypoeutectic heat-treated white iron. So you're looking less than half the wear if we could get it right. The challenge is getting the white iron, which I've shown here in the brown color, inside of a steel case strong enough to take those pressures and duties. What we did is we cast 3 identical pieces of white iron, which were going to make the internal liner. Engineering-wise, we didn't want this to be any part of the structural strength. We just wanted it to be there for wear. As long as that is wearing away, it will be able to take the pressures because those are unaffected. Big engineering challenge is we had to move away from the piping standard. To get the liner in there, this was fabricated into 2 sections, which means it then became a pressure vessel. and all the welding codes and all the FEAs and all the certification that came with it. Hofmann's has that engineering capability, and we're able to do that in-house. So just an example of the FEAs that we conducted. So the test, our friends up in the Pilbara put this into service. In 2016, they ran it for 4 years. They sent it back to us because there was a problem with it. One of these sealing faces had eroded out because of a problem with the mating part. But it gave us an opportunity to measure the liner. Now, remember, this is wearing out in 18 months and had to be replaced. So when Warren and I did the measurements, we saw that the highest wear is very close to the mating face, about 1 millimeter of wall thickness per year. So after 4 years, we'd lost about 4 mil in the highest wear areas. The whole internal bit was less than 1 millimeter per year. So we could safely estimate this has got 4 more years of wear life on the liner. All the steels that we use are weldable because we had to weld it into a pressure vessel type. So we can repair these faces, and that's be about 1/3 of the cost. So what we're going to do with this now becomes a serviceable item. We're going to weld up the wear faces, we're going to re-establish the gramophone finish to make a good seal, and it's going to go back to site. The last case study, now I apologize for the dark picture, this is our friends at Alcoa. They have numerous of these ball check valves, quite big, M72 this size is. And the problem that they have is these were only making 1,800 hours. So that was determining the campaign time for this section of the plant. Now what was happening is you've got this steel ball in a caustic slurry that is doing the non-return bit, but under flow it comes up to the red region and it rotates in the slurry. Now you can probably just see the ball peeking out there, but that's how it works. It comes up in the slurry and then it rotates. And the retaining pins are a high quality tool steel, induction hardened to help with the wear. I think you can see what's happening there. The retaining pins are wearing out by abrasion, by wear. Why this is happening is because the surface area of the steel ball is very, very large when it's rotating compared to the very tiny contact point on the retaining pins. Second thing that's happening, because we induction harden these, as soon as it's worn down, this is a worn part that's been prepared and etched, is the induction hardened layer on the outside is worn away and exposes this soft core. So we've got about 58 Rockwell on the induction hardened layer that's already worn away, and we've got exposed core of about 30 Rockwell. It doesn't slow down the wear process. Our proposal was to hard face. So we got a big fabrication area and we do a lot of hard facing. 6% carbon, 26% chrome, I believe, just a standard chrome carbide weld overlay to about 8 to 10 mils, and we put it back into operation. 3,600 hours, 8 mil of wear, so it made the campaign, and they're certainly thinking about putting it in for a second campaign. So all successful stories, and I think the bit that I want to talk about with Hofmann's is that we learn from other sectors, other products, and then we apply it. The most important thing to us, it must significantly benefit the user. Now I know we all like to get involved in the science, the metallurgy, and new things, but for us, this is the primary thing. It must benefit the user, and the quicker the benefit is realized, the better. Significant extension to life is a great benefit for the customer, right? And that's one of the things we look to do on a continuous basis. Underpinning that product improvement is all the engineering and metallurgical knowledge that Hofmann's has. It's all collectively used to benefit the customer. Okay, so thank you for your time. I know it was a very quick presentation, but.
Any questions? Paul? Yeah, just a quick one on the retaining pins. Did you look at options like a through hardened, like a tool steel kind of material that would get you the hardness but all the way through the pin? Was that an option?
The options that we looked at was welding a complete bit of wear block onto a mild steel plate or the overlay. We didn't consider a fully through hardened tool steel. The reason why is because I actually took it off the photo, but there is a ring that holds those pins together, and that ring is welded. So it has to be weldable as well.
Yes, of course.
Yeah. So mild steel was the appropriate choice for that part of it,
Yes.
and the hard facing for the wear area.
That's good.
Yeah.
That makes sense.
Yeah.
The pipe with the multiple flanges on,
Yes.
you went from shed 60 to sort of diamond, white iron. Was there any sort of thought of using other materials, like even overlay in the pipe or something like that would have improved it? Would have given it
That's a really good question. But we knew white iron. We knew it would work.
Yeah.
So we tried it.
Yeah.
And it's that kind of, how can I say, that cross-pollination of ideas and products is what we can do quickly. We can replicate it very quickly in the supply chain. We're confident it's going to work. We can convince the customer by using analogies to this product. So we go for it. Like Hofmann doesn't get too bogged down in the science. It sees a customer need. It has a solution. It goes for it in the spirit of John and Eric Sr. that they've done for the past 50 years.
Yes?
Does Hofmann hold any patents?
They do. They do. They do hold patents, particularly on HPGRs, on the edge protection. We don't tend to patent a lot of things. We believe in the continuous improvement cycle. So our differentiator is always to make a better product. We don't want to stay still. So if we patent something now, we should be looking for that next benefit.
Aren't you concerned about competition?
Competition must make better products. It's as simple as that. We don't always win. We don't always get it right. We fully admit that. But certainly most of the time we get it right. And it's the continuous improvement drive that keeps us ahead of the competition, or at least keeps customers talking to us. What we find is OEMs want to sell spares. It's good business for them. They want to sell as many spares as they can to a certain spec. And that's a nice gap in the market for us.
Steve, I've got a question. If you're making the mantle supports last 2-3 years, how does that impact on your commercial sales for those products?
Well, they weren't our products to start with.
But I mean, from a repair business point of view.
I think it's a great question. We do repair. There is a repair option, and it's about 100,000 less than the new forged head. But once they see the benefit of that, I mean, the campaign time is really decided by the liner. That's when they get in, they look at their head, and they can decide, all right, we can run this another campaign or not. If that comes out, it's a 16-week repair. You have to find a repairer. You have to trust the repairer. You're talking over 100K to get it repaired. So we offer that, but we really encourage the benefits of the forged head version.
But in the long term, you'll end up reducing your repair.
There's a lot of heads out there. And as I said, miners are very good at breaking stuff. Very, very good.
Cool.
Yeah.
Well, thanks very much, Steve.
Okay, pleasure.